Welcome to this lesson on completing the square. Now suppose we had a quadratic that had no c value. It looked like this, x squared plus bx. What would we do with that? Well, we'd want to complete the square in order to solve for x. So let's take a look at that process. We take the b value, we divide it by 2, and we square it. And then we add it to the end of the quadratic. In other words, that becomes our c value. Once we do that, we factor our quadratic and we find out that now our quadratic is a perfect square. In other words, it's something times itself. In this case, it's x plus b divided by 2 squared. Let's take a look at an example. In this case, we have x squared plus 6x, but we have no c value. We're going to take our b value, 6, divide it by 2, square it, and that becomes our c value. Now we know we have a perfect square, and we can factor that quadratic like this, x plus 6 over 2, which of course is x plus 3 squared. Pause now and copy everything on this slide. Let's look at some examples. X squared minus 14x, we have no c value. So our process says we take the b value, or negative 14, we divide it by 2, and we square it. That becomes our c value. Now we have a perfect square, and we can factor that to be x plus negative 14 divided by 2, or x minus 7 squared. Pause now and copy this example. Our second example, x squared plus 9x with no c value. Our b value is 9, so we're going to take that, divide it by 2, square it, add it to the end of our quadratic. Now we have a perfect square quadratic, which we can factor to be x plus 9 over 2 squared. Now, I want to point out that here we have a fraction, and you'll notice I did not change 9 over 2 into a decimal. When we're working with quadratics and we are factoring, it's a lot easier to see the factors if you leave it as a fraction. So do that. Leave those things as fractions. Pause now and copy down this example. One more example, x squared minus 4x, no c value, so we're going to take negative 4, divide it by 2, square it, add it to the end of our quadratic. That gives us a perfect square quadratic, which we can now factor as x plus negative 4, or our b value, divided by 2, squared. So that gives us x minus 2 squared. Please pause now and copy this example. Now here are the steps. I've summarized the steps for solving a quadratic by completing the square. What we've done so far is just practice the process, but you can actually use completing the square to solve for x in quadratic equations. The steps are to collect the variable terms on one side of the equation and the constants on the other. Number 2, we're going to divide both sides by whatever the a value is, because we need a to be 1. We're going to then complete the square. Now we just went over 3 examples of that process. Then we're going to factor our quadratic as a perfect square, and then to solve, we're going to take the square root of both sides of the equation and then simplify that, or solve for the values of the variables. Please pause now and make sure that you have all of these steps written down in your notes, because you're going to need them to follow along with the examples that are in the rest of this presentation. Here's an example. Here's example number 1. We have x squared minus 12x plus 20 is equal to 0. So in this case, b is negative 12. A is already 1, so we don't have to worry about that. But we do have to collect the variable terms on one side and the constant terms on other. So that means I had to subtract 20 from both sides of this equation. And I end up with x squared minus 12x is equal to negative 20. I don't need to do step 2 because A is already 1, so I don't need to divide everything by A. But I do need to do the rest of the steps. So now I'm going to complete the square by dividing negative 12 by 2 and adding it to both sides of the equation. It's very important that you add it to both sides of the equation. So I have negative 12 divided by 2 squared. That's actually negative 6 squared. And that gives me x squared minus 12x plus 36 is equal to negative 20 plus 36. Now we're not done yet, but this took more than one slide. So pause now and make sure that you have this part of example 1 written down. Now we go on with step 4. We're going to factor our perfect square on the left side of our equation, and it will factor to be x minus 6 squared. And then we're going to simplify the right side of the equation, and that ends up being 16. We're going to take the square root of both sides of the equation. Now when you take the square root, you must account for the negative case and the positive case. So don't forget to put the plus and minus in front of the square root. And of course, square root cancels out a square. So we end up with x minus 6 is equal to plus or minus the square of 16. The square of 16 is 4. So we end up with x minus 6 is equal to plus or minus 4. And now we're just going to solve for x. And x can either be 6 plus 4, which is 10, or 6 minus 4, which is 2. So our x-intercepts are 10, 0, and 2, 0. Pause now and write down this example. I have 2 more examples, so let's take a look at the second example. In this case, you'll notice A is not 1. So we're going to start by collecting all of the variable terms on one side and the constant terms on the other. In this case, we need to add 45 to both sides. Now I'm going to divide everything in this equation by 3 because A is 3 and I need A to be 1. Next, I'm going to complete the square by dividing 6 by 2, squaring it, and adding it to both sides of the equation, and then simplifying that. So let me go back. So now on the left side of my equation, x squared plus 6x plus 9, I'm confident that's a perfect square because I went through the process of completing the square. And I'm going to need to simplify 15 plus 9 by adding them together. So pause now and write down this much of the example in your notes. Now I'm going to factor the left side of the equation. I know I have a perfect square, and it is x plus 3 squared. And I simplified the right side of the equation and ended up with 24. My next step is to take the square root of both sides. Don't forget to put the plus or minus in front of the square root. And now I'm just going to solve for x. So I end up with x plus 3 is equal to plus or minus 2 times the square root of 6 because I have simplified the square root of 24. And I'm going to solve for x by subtracting 3 from both sides. And so I have negative 3 plus or minus 2 times the square root of 6. Those are my x-intercepts. But I am going to write those as a coordinate pair. Now in this case, I don't need to write it as 2 separate coordinates because the plus or minus does tell me that I have 2 of them. So I can write it as negative 3 plus or minus 2 times the square root of 6, comma, 0. Pause now and copy down the rest of this example. Now, if you have questions, be sure and bring those to class. I know that you probably do have some questions, and we'll do lots of practice in class. See you then.